Hello everyone, I'm going to explain to you about the next chapter on clustering. This is the table of content for this chapter, which, as you know, clustering is an unsupervised learning approach. So we'll be going to look at the concepts as well as covering the partitioning methods and the hierarchical clustering methods. For the introduction, I will cover on the concepts, application steps, and approaches. As you all know, there are three kinds of machine learning approaches. The first is supervised learning, which we have covered in chapter 4. So this is where you use a data set which has labels, the category, the class, and from there, the machine learning algorithms would learn based on the labels. In this chapter, we're going to look at unsupervised learning, which the machine learning algorithm would learn without having the class label. Meanwhile, the third category, which is the reinforcement learning, is where the algorithm would learn based on the interaction with the user and also to learn from the correct or incorrect classification. The unsupervised machine learning algorithm would be able to find all kinds of unknown patterns in data. You have heard about the word clustering before, especially from the case of COVID-19. Unsupervised methods help you to find features which can be useful for categorization compared to supervised methods where you have you can identify the features and you tell the algorithm which features would be suitable by doing several experiments. Clustering does it differently. It will help you to find the features not from the columns but from the rows. It would identify the similarity between the objects. This is done using unlabeled data from a computer, which makes it better than the supervised learning, which requires labeled data. On the right side, you can see issues with unsupervised learning. It is harder compared to supervised learning tasks, but we can know that results is meaningful because the data algorithm will be able to find data which are similar with one another. The unsupervised learning is needed despite of the difficulties because annotating large data set is very costly. Hence, we want to be able to know the patterns from data that shares this high similarity. This slide tells you the clustering concepts. A good clustering is a method that will produce high quality clusters, which means that object which has high similarity would be grouped in one cluster. So you can see the circles here. The circle is one cluster. From this example, you can see that the green objects are grouped together, but there are objects which is not grouped together because it is far from the other objects which has high similarity with each other. You can see also the differentiation between the cluster green, cluster pink, and cluster red, which they are again according to their similarity. In this situation, the similarity based on the color. So we can define a cluster as a group of data points that are similar to each other based on their relation to surroundings data points. The clustering quality is based on intra-clusters distance. Intra-clusters distance meaning clusters which is points which are similar, distance is minimized, meaning we want to make sure they are together, and interclusters distance is maximized. We want to make sure that one cluster distance with another is maximized. So in the bottom left here, you can see the quality based on similarity measure and based on its implementation as well as its ability to discover some or all of the hidden patterns. Let us look at an example. The clustering analysis is based on. So just now we have looked at the clustering concepts. Next, let's look at the applications of clustering. The applications of clustering cut across many areas. In biology, we can identify taxonomy of living things, meaning we identify the objects or the creatures which are similar to one another, and the species similarity would be able to form family and taxonomy of living things. In information retrieval, we can group documents or reviews based on the similarity of topics and the content as well as weighting review. Meanwhile, for land use, we can identify when we are given an observation database of land usage, we identify the activities on the land usage based on the allocation. In marketing, marketers can discover distinct groups in their customer bases to develop targeted marketing programs. So imagine that you have records of what each customer buys. From there, we can identify customers that has similarity of preferences with each other, and we can give vouchers to them, or we can recommend to them to buy other items. In city planning, we can use clustering to identify groups of houses according to their house type, value, and geographical location. Based on this example, you can see the importance of similarity in clustering. The steps of clustering can be divided into these 6 steps. The first step is feature selection, where we can identify information concerning the task of interest, and then we can minimize information redundancy. Imagine that you want to come up with an analysis to build clusters of people who has same symptoms of disease. Then we want to look at whether each person has symptoms 1 and symptom 2 and symptom 3. So all of this is based on similarity. Under proximity measure, we can use again the similarity to measure 2 feature vectors. And we can then use clustering criteria, which is expressed via a cost function or sum rules. The clustering algorithms, here is where you choose the algorithm for you to calculate and for you to derive the clusters of objects. Then we can validate the cluster and interpret the results. There are many kinds of clustering approaches. There are 8 kinds as shown in the slide. The first is partitioning, the second is hierarchical. We will also cover density-based and grid-based. The bottom line is much more specific. Look at partitioning clustering. In partitioning, we construct K partitions and then we evaluate them according to some criteria. For example, we want to minimize the sum of square errors, and the algorithms that can be used is K-means and K-midoids. In hierarchical clustering, we can create a hierarchical decomposition of the set of data using some criterion, such as the Diana, Agnes, and Birch algorithm. Meanwhile, density looks at the high density or points which has high frequency, and this is called density and can be detected by the B-scan algorithm. The grid-based algorithm would try to come out with grids and quantify the object space into finite number of cells to be able to classify the clusters. Let us first look at the partition-based approach. In this partition-based approach clustering, each cluster is associated with a centroid, which is called the center point. And each point is assigned to the cluster with the closest centroid. And the number of clusters, the value of K, must be specified manually. We can look at the basic algorithm as shown here. First, you have to select value of K as the initial centroids. Then you repeat this process to form K clusters according to the number that you have identified by assigning all points to the closest centroid. Then you recompute the centroid of each cluster and you repeat this process until the centroids don't change. The K-means algorithm is an example of partition algorithm. The algorithm attempts to determine K partitions that minimize the square error function. So again here we use the square error function as a cost to determine whether the number of partitions and the object assignment is already completed. The formula is explained by E, P, N, and I. E is the sum of squared error for all objects in the dataset, while P is the data point and the space representing an object, and MI is the mean of the cluster. On the right side, you can see the algorithm as explained earlier. We can know that the cluster is already converged when we measure its sum of squared error. Let us look at an example. For simplicity, we will use one-dimensional data and we specify the value of k to be 2. So as you know, the first step is for us to set the value of k as the number of clusters. So here we want to develop 2 clusters. We can estimate this number of k based on the size of data. The data that is given to us is this: 1, 2, 5, 6, and 7. So from this, we want to identify which data would be able to be assigned into 2 clusters. The k-means algorithm started with us identifying 2 points randomly. Because we have k equals to 2, we randomly select 5 and 6 as initial centroids. So we assign centroid for each cluster. We know that 5 and 6 as the initial centroids. Then we repeat process number 2 until process number 5. We assign each data to the cluster of its nearest centroid. This nearest centroid is the similarity function. So we look at 1, 2, and 7. We calculate the distance between 1 to 5 and 1 to 6 because we know that the distance between 1 to 5 is smaller compared to 1 to 6. Then we assign 1 into the cluster 5. Next, we identify 2. 2 is closer to 5 compared to 6. We assign 2 into cluster 5. We repeat the process for 7. Because the distance of 7 to 6 is smaller compared to the distance between 7 to 5, we assign 6 and 7 into one cluster. From this, we can calculate the mean of each cluster. We know that now that 1, 2, and 5, the mean value is 2.6 and the mean of the second cluster is 6.5. Then we update the cluster mean. 2.6 and 6.5 now becomes the new mean. And this replaces 5 and 6 as the initial. We repeat this process until E converge, which eventually we would get this 2 clusters, 1 and 2, as one cluster because the distance between 5 to 2.6 and distance between 5 to 6.5, it is smaller between 5 to 6.5. That is why 5 now goes into cluster 2. 7 stays in cluster 2 because its distance between 6.5 is smaller compared to its distance between 7 to 2.6. After we get the cluster again, we update the mean of the cluster and we get the new cluster, and we repeat this process until no object is reassigned into new cluster. After that, we calculate the error. This error is calculated based on the algorithm, based on the equation given earlier, and from there we can identify the error dissimilarity. The next algorithm is k-medoids. K-medoids is different compared to k-means because k-means has a weakness as it is sensitive to outliers because it is totally depending on the centroid value. The k-medoid is different because the medoid takes the most centrally located point rather than value of average or mean. In contrast, a centroid or means is not necessarily in the center of a cluster for k-medoids algorithm. The algorithm for k-medoid is shown in the picture. Here on the right side, I show you the example directly. We have this data 1, 2, 4, 5, 10, 11, 12, 16, 17 and 18, and this time we use k equals to 3. When using k-medoids, the first step is again to randomly select 1, 4 and 12 as initial medoids because in this example we use k equals to 3. We repeat this process but we identify the nearest medoid to the selected points. So 1 and 2 is into one cluster because its distance is smaller compared to 2 to 4. 4 and 5 is closer because its distance of 5 between 1, 4 and 12, it is smaller 5 with 4. And we repeat the process for the rest of the data given to us. And we can calculate the error and randomly select new points as the new y, and we continue the process until E converge. We can evaluate the cluster by using elbow method in the Python. And the silhouette value measures how similar an object is to its own cluster, which is called cohesion, compared to other clusters, which is called separation.